A lot of the hardest lessons that I had to learn had to deal with quote unquote scaling myself up. You have to learn to stop doing things yourself. Even though it's hard, and I'm saying it's hard, you shouldn't be afraid of it.
Hello there, everyone. I'm Polak, and welcome to Confluent Developer, where we explored the wild, weird, and wonderful journeys of software developers building systems that hopefully don't wake us at 3 a.m. This episode, I'm interviewing Sage Pierce from hacking on Java Swing apps inside a top secret defense lab. Yes, Swing, it still exists. To becoming a principal engineer obsessed with domain-driven design, Sage has seen things, monolith things, microservices things, pay-as-you-go brr things. His journey takes us from college side gigs and governance security clearance all the way to event-driven architecture, scaling through people, and even inventing a new streaming patterns like IMI, all while discovering the universal truth of engineering. If your name isn't Git blame, you're on call. We talk growth, leadership, streaming data, and how to avoid building yet another distributed hairball. Let's get to it. Hey, Sage.
Hey, Addie. Yeah, excited to talk tech and talk streaming.
I know you've been recently promoted, so congratulations. Kind of like crossing the chasm in between staff engineer to principal engineer. It's a big deal. I don't know if engineers know it at home, but it's kind of like when you reach a senior level, it could be like, a finite level for some folks. And getting anything beyond that, it's definitely very, very, it shows that one is really eager to learn and grow and do what needs to be done in order to continue pushing forward. So I'm curious if you have kind of, learnings or things you had to learn or, de-learn, also forget, put it that way.
Yeah, honestly, all of the above. I think every person's, every engineer's journey to the levels of staff engineer and principal and then technical fellow after that. I know there are different terminologies at companies, but every engineer's journey to those levels, I think, is unique. Everybody has their own experiences and a unique story to tell about that. So what I can tell you is everything about my journey is very unique to me, I think. I can tell you that I've been at this job of software engineering. I've been doing it for about 15 years. I got my start in 2010, and since then, similar to all engineers, it's just been a long series of lessons and learning and growing. And as far as the transition from sort of a junior or senior level into staff and principal goes, for me, the lessons, a lot of the hardest lessons that I had to learn had to deal with quote unquote scaling myself up. And that's a quote from one of my managers that I still work with. He's not currently my manager, but he's somebody I look up to a lot. And one of the first things he told me as I was getting further on into my career was, you have to learn to stop doing things yourself. I am an engineer that I really, really enjoy getting into the weeds, solving the problem, not just saying what the problem is and then saying what a good solution is. I get really focused on if I know what the right solution is, it takes a lot of willpower to not just go and do that thing. But as I found out over time, as you build more and more things, people start looking to you as the person of support. You become whether you like it or not, empirically, you become the first person that gets contacted when something you built breaks, even if you've tried to hand that thing off to another team. You are, if your name is in the Git blame, you're the person that gets tagged first. So one of the hardest lessons I've learned in the transition from senior engineer to staff engineer to principal engineer is focusing less on doing the work, doing what I used to consider the work, which is writing the code, and more focusing on how can I teach the engineers around me to do that thing, and help coach them up when they do something differently than I would have done it. And if I think that the way I would have done it is better, I try to explain why that is. And sometimes I'm not always right, and that's even another opportunity for me to grow when there are disagreements, and I learn that the way that I would have done it wasn't the best way to do it, and that happens as well. So it has a lot to do with learning from others and teaching others as you move up, rather than just doing the work yourself.
Yeah, it's this is going to stick with me for a while. It's like scaling through others and learning to scale yourself in the organization, knowing that our knowledge is finite. We only have 24 hours a day, no matter what we do. We can have other resources, infinite other resources, but time is really as finite. And so this is a really interesting learnings. I wonder if you had like something distinctive between staff and principal that you can think of.
Yeah, for sure. Obviously, you mentioned I was promoted last year, and that promotion happened while I've been at Indeed. So I've been at Indeed going on 5 years now. The biggest difference to me between staff and principal, generically speaking, is this transition from being a tech lead for a group of engineers, and instead being a tech lead that knows how to coordinate amongst different groups of engineers in different organizations. So I'll give you an example. This ties a little bit into the talk I'm giving next week. I'm sort of a domain-driven design junkie. You can see some of my domain-driven design books behind me on my shelf. And when I use domain-driven design and domains in particular when talking about different teams and what they're responsible for and how those domains and those teams talk to each other. At Indeed, the current team that I'm a principal engineer for has to deal with managing the ingestion and management of intents to hire. So we maintain the data storage and data flow of how employers say, I'm looking for a job to hire, or looking for a person to hire for a job. And then there are other domains that are responsible for some data that is completely orthogonal to the hiring intent. That might be information about the companies themselves. It might be other domains that are responsible for deriving data from other data that employers give us. Moving into the position of principal engineer requires much more of not just being a tech lead for all of the services that the subset of teams that are in a particular domain are working on, but then understanding how that domain relates to other domains that other teams are responsible for, and not just internalizing the communication or the necessities of communication between those domains, but also working with the members on either team and either organization that are designing and building out those domains.
Cool. And also I'm guessing like finding the dependencies and trying to unblock. Yeah, it's fascinating going from staff to principal. I'm sure it's a lot of work in Code Studio for finding the ways to do it effectively and efficiently.
Yeah, I do feel compelled to tell you a part of my story in particular. I did not want to be promoted to principal engineer for quite a while.
Okay.
My manager at the time, I think we first broached the subject of being promoted from staff to principal about 2 years before it actually happened for me. And I'll be honest, the main reason I didn't want to be promoted was that I knew then, as I know now, that I very much like doing the coding work, right? But I saw my colleagues that were already principals at that level. They spent much more of their time in meetings, and I was already spending a significant percentage of my time in meetings. And when I would see the calendars of my principal engineer colleagues, and I would see 50, 60, 70% of their week blocked off for meetings, that just didn't appeal to me. So growing into principal, I had to really get my manager and the leadership apparatus to agree that if this was going to happen for me, I wanted to do it at my own pace. I wanted to maintain a connection to the actual code being delivered, as well as taking on those extra responsibilities of scaling myself out through others.
Yeah, it's amazing to me how we have more authority to define the way if we're willing to, first of all, identify what are the things that we enjoy and we want to do, and second thing, be able to communicate it in a way that other side can relate and understand. And it's yeah, I think you did that because you were able to kind of shape your role in the way that where you can continue to enjoy it. And also satisfied the rest of the leadership and company needs, put it that way. So congrats, that's super exciting.
Thanks.
Yeah, so we're here to talk about challenges, we're here to talk about work, but I was curious, do you remember your first ever job?
Oh yeah, absolutely. So I mentioned I got started about 15 years ago. So 15 years ago, I got a job while I was in college. I was at the University of Texas. Go Longhorns! I'm a big Longhorn fan. You can see my Build-A-Bear has got a Longhorn
Nice.
on it. So I knew when I was in college that I didn't really know for certain in college that I was going to be a software engineer when I got out. My major was electrical and computer engineering. I was really into renewable energy, but also microprocessing. So the programming I was doing was really kind of systems level, embedded processing level in school. So I didn't know that I would be really into high level programming, kind of what I'm doing now with JVM languages and whatnot. But I knew I needed to get a job because I was low on cash and I was a poor college student. And I applied for an open position at a research lab on a research campus affiliated with UT. And the name of that research lab was called Applied Research Laboratories. Mm-hmm. And they hired me as initially as a software technician. And that was just a fancy way of saying I was a student that was being paid part-time to work at the research lab. And this research lab had federal contracts with the Department of Defense. So there's a little bit about my work I'm not supposed to talk about, even though it was like more than 10 years ago. And I'm pretty sure, I don't think I was really working on anything that was classified, but I had to go they made me get a government clearance and whatnot. But that was just because I was around classified things. But that job I didn't know it at the time, but that job lacked every single bell and whistle related to software engineering that you could imagine. It being a research lab that was affiliated with, or that had federal contracts and needed to be security compliant meant that they were very, very picky about the tools and technologies that they allowed you to use. So my first development environment was a bare bones Linux laptop, or not laptop. It was a tower actually at first, and they gave me a laptop. And that computer, I wasn't allowed to take that computer home. I had to work. I had to stay at the office. And my coding environment there was no IDE. It was a shell script and a graphical text editor called gedit. Yes. And I had to learn a lot of things that I take for granted now, like how do I compile Java locally, how do I run that application, and the applications I was working on, and this isn't sensitive or anything, but I was working on applications that helped defense contractors monitor the state of our GPS satellites. So they were Java applications written with Swing. And I believe Swing is still available as an API in Java. I don't think anybody uses it. I don't think they should. But everything I was working on at the time had to do with Java Swing development.
Yeah, maybe those, Java jobs that you created are still around and running somewhere, monitoring
I
and
hope
everything.
Not. I can
Who
only
knows?
imagine.
If it works, don't change it unless there are new requirements. But
Yeah.
that's really super cool how you did the transition from that world into software and kind of working on working also working at the governance. It's always interesting because there's so many cool projects that unfortunately people cannot share. But
Yeah.
a lot of very cool things.
Now, a quick word from our sponsor. Confluent Developer, the podcast, is brought to you by Confluent Developer, the website, which has everything you need as a developer of data streaming systems. And it's completely free. We've got curriculum, hands-on exercises, executable tutorials, the online data streaming engineer certification, also free, a way to find a meetup near you, those are free. Everything is there. I really want you to be successful in your journey as a data streaming engineer, and this is the site that has what you need. Check it out at developer.confluent.io. That's developer.confluent.io. Now back to the show.
Okay, let's do a jump forward. There's a lot of challenges, software challenges, architecture challenges, or as you mentioned, like domain. How do you even define like owners? How do you split it? How do you create the right interface and so on? Maybe you want to share some recent challenge that you worked on or you're still working on and some learnings around that.
Yeah. So I'm going to take this question. I'm going to bleed it into kind of what this overarching problem that has permeated the last 10 or so years of my professional life. And that challenge, I refer to this challenge as event-driven views. And the setup for this challenge is pretty. My guess is it's pretty common to a lot of people that have been in tech for any significant amount of time, especially anybody that's worked at companies that started with large monolithic structures and found out that it doesn't scale well. So the problem statement starts like this. Most really successful tech products, software products, at least prior to 5 years ago and in the previous couple of decades, they usually started really quickly with somebody creating a database with a nice schema and then setting up a service in front of it and then demonstrating value and then launching that to production. And then as they wanted to add new things, they would just add new things to that service, add more data to the database. And then as the product might have grown, they would have had other internal uses of consuming that database to run things like analytics. Maybe they attach some change data capture to the database so that they get real-time data propagation downstream. By and large, what you find out is if the company has a long life, has a longer than non-trivial life, and they keep building on that initial structure, what they end up with is a giant mess of a database and monolithic service and monolithic architecture that becomes difficult to work on, right? We've heard monolith might as well be a 4-letter word in the world of software engineering and software architecture.
It's true pain.
Yeah, I think everybody's familiar with the pain that those kind of monoliths can solve or can induce. So what ends up happening by and large, and this was really popular throughout the 2010s while I was progressing from junior, senior into staff software engineer, was the approach to the approach for a solution for monolithic architectures is start breaking it down into microservices. So microservices, in my view, should imply at least a little bit of knowledge and background on domain-driven design, because you can't have microservices kind of spawn from the world of domain-driven design. Mm-hmm. Having an understanding of domain-driven design and leading into creating microservices was pretty important for me. And I was fortunate at my second job that I had. They were pretty adamant that they spend a good amount of resources on up-leveling their engineers. And one of the topics that we would talk about was domain-driven design. So I had a pretty good academic start on learning about why you break up monoliths into microservices and how you use domain-driven design to do that. And it wasn't too long after that I stumbled into this problem that kept on coming up of, okay, we've broken this monolith into microservices using domain-driven design.
Right.
And now the problem is we have use cases like analytics, or we have use cases that are domains that span other domains that we've identified. We need a domain that aggregates data from domain A and domain B, and we need to keep an entity up to date in real time based on changes to these other domains.
Right.
It used to be the case if you had a monolithic architecture, all that data was in one place. You could just, it was easy, create that view off of the data that spans multiple bounded contexts. It's all munged together in the same database anyway. Seems like a pretty straightforward thing to do. Obviously, you can't really do that with a microservice architecture. And even doing that, even in a microservice architecture, implies you have some form of an event-driven design baked into your architecture as well. Because how does any downstream domain know about data changes in an upstream domain if that domain isn't producing events?
Right.
So we've already talked about like three pretty large concepts that have entire books dedicated to them: domain-driven design, microservice architecture, and event-driven design. And those all lead to this, are all a component of this problem that kept coming up of, we need to be able to do something interesting with a view of data that spans multiple bounded contexts. That could be analytics, it could be indexing into a search engine for multivariable search, it could be its own domain that other people want to incrementally operate on, but keep that data replicated from keep certain data replicated from other domains. There's a wide gamut of use cases.
So let me just see if I follow up everything you said. So essentially, you have you broken the monolith, right? You turn it into microservices. Each one of them has their own, streaming data from place to place and serving whatever requirements they are responsible and owns. And suddenly, you get more requirements that are now more kind of like data focused, like you have analytics, you have different services that needs to aggregate information, right? And this is where kind of like new challenges appears in the system.
Mm-hmm.
Okay,
yep,
cool.
That's exactly right. And the extra compounding factors that make it more difficult is you find out that one of the benefits of microservices and domain-driven design is you can separate things, but as those things become owned by different teams, those teams have different preferences. One team might want to use a relational database, or it might make sense for their domain architecture to use a non-relational database. Another team might be using Kafka to produce their events, but they might be using an AWS native solution, so they might be producing events to SQS.
Right.
And one of the things that I find really common is that, given that Kafka is relatively young compared to message buses in general, some of the older companies and tech stacks will use something like RabbitMQ or any older message bus technologies. And what the compounding factor there is, well, any solution for an event-driven view that you need has to be able to account for this polyglot infrastructure, different databases, different message buses, and whatnot.
So the tech stack is different. Right. Yeah. So the tech stack is different. So what do we do?
Mm-hmm. Yeah, absolutely. So the nature of a polyglot architecture, and then the nature of the eventual consistency of an event-driven system, those all lead to a unique set of problems if you're trying to solve come up with a solution for this abstract need to see a view, an up-to-date, real-time view of the data that you care about that needs to be joined across domains. One of the things I'll touch on in my talk next week is, this sounds really similar to like GraphQL, right? To like query federation. I have data across multiple domains that I need to join on demand and be able to view that data. Where event-driven views differs from something like query federation or GraphQL is that event-driven views is much more back-end oriented. You want to you know the exact services you need to hit, so it's not exactly federated, and there's a lot of throughput and latency constraints that you'd like to account for that aren't necessarily addressed in GraphQL. And in addition, not just querying the data, but notifying your downstream consumers when that view that you're keeping has changed becomes not just desirable, but a requirement in a lot of cases, because a lot of domains will care about when the join data changes, not just the independent data from the upstream domains change. So it's a long-winded way to explain the entire domain of this problem of event-driven views, which is what I've been working on, helped come up with several solutions in the past decade or so. And the one I'm presenting on next week has to do with this stream topology that I have termed ingest materialize index. So that is in the name of my presentation next week, which I shorten that to IMI. And IMI is all about coming up with a maximally simple solution, attempting to be maximally simple solution for event-driven views.
Cool. Can you give us like a brief, this is how we build it?
Absolutely. Yeah, so IMI, ingest materialize index, I name it that because it's based off of these three stream stage. Each of those words maps to a stream stage. So the way IMI starts off is you ingest events from any producers of events, and those events should indicate, ideally they should be domain events, but not everybody has those. Sometimes they're just raw CDC events. But these events should indicate when data that you might care about viewing has changed. So that ingest stage is responsible for consuming whatever the raw schema is upstream that you don't control because the producers control that schema. Consuming those events and then using the data in those events to relate the foreign data, the foreign keys in that data, to the view keys that need to be reprocessed or rematerialized. So in ingestion, you have this responsibility of correlation. And then ultimately, once that correlation is done, you produce commands. So this is CQRS, command query responsibility segregation, is another concept that's baked into this, not just the problem, but also the solution. So ingestion is responsible for correlating the changes in foreign domains to the domain of your view, and then generating commands to reprocess that view. That feeds into the second stage of IMI, materialization. Mm-hmm. And in materialization, what happens is you take these commands, and in all of our cases, we apply micro-batching, which is take in elements or take t duration of commands, whichever one comes first. And then you take that batch of commands and you dereference, is usually the word that we call. We dereference all of the data that's related to the view that you want to generate. And then we feed that aggregated blob of raw data to a generation phase. And then that generation phase produces all the views that need the current state of all the views that need to be indexed. And those get put onto another Kafka topic. And that feeds into the third stage, which is index. So each of those views can be indexed to any number of destinations, including a database where you can look up the data on demand, or you can have CDC from that database, which we also do, which lets you let your downstream clients know when that data has changed.
Cool. So I'm guessing, thinking through, there are some requirements that this system has to comply to. Like I'm thinking maybe exactly once, right? If anything changes, there's some command or operator or something happened to the data, and we are sending those events as changes. We need to make sure it actually arrives at the destination, right?
Yeah, so it ends up being the case with all of our use cases that we don't care about exactly once, we just care about at least once. So that is our minimum level of guarantee. You will get these changes will flow through the system at least once. The other thing I wanted to call out before we move on to the next thing is the architecture itself. I'm one of the things I'm happiest about with it. It's number one, it's abstract, so it can be applied to several different streaming methodologies. Okay. But it requires a very minimum set of resources, which is one of our requirements. We would like to not have to replicate our data all over the place just to make it compatible with a given tool. And the solution, the bare solution that IMI proposes is a single application with at least 3 stream processes in it and then 2 Kafka topics. So that absolutely minimizes the number of resources. We get at least once processing, especially using Kafka as the intermediary between the stream stages, and we get robustness because we know we won't. We have a library that we use. Then this is also a part of my presentation, a bit of a passion project that I've been working on called Atleon. And it's a lightweight stream processing framework that gives you the guarantee of at least once processing, regardless of what infrastructure you're consuming from or producing to.
That's really cool. Well, I'm very excited for your talk, and if anyone is watching it afterwards, it's going to be available on YouTube as well, so you can always catch up with that. I'm curious, is this library ever going to be open sourced, or do you think about that?
Yeah, it is open source.
It is open source.
Yep. You can check it out at atleon.io.
Very, very cool.
And the name is comes from at least once, at Leon. So that's it's been a project that I've been working on for going on through might be 4 years now.
Wow. Okay, that's some of the best projects are the ones that we work on for a long time, in my opinion. So very cool. All right. Any learning so far that you want to share before we're wrapping things up? From thinking about the system, designing architecture, pitching the system, also getting buy-ins from some folks as well. I'm sure you've been working across the company with multiple teams.
I think my biggest lesson with all of this stuff concerning not just event-driven views, but stream processing in general, it's super, super powerful. But there is a pretty big learning curve when you're going. Everybody starts out their first project is or their first business project is usually create a REST endpoint or maybe a gRPC endpoint, and it's really intuitive to think request response.
Right.
Moving into the world, and this is the challenge that I face a lot when designing asynchronous systems and teaching other engineers about asynchronous systems and stream processing is you don't really know what's going to happen after you fire an event off. You agree to a contract and you produce it, and then the things that happen after that, not only are you not really sure anybody's going to do anything after you fire that event off, but some of the things that happen might be non-intuitive. So it's definitely, I find asynchronous processing to be extremely powerful, a very fun problem space, but a pretty high learning curve, but a learning curve that's definitely worth it. Because it definitely moves you to the next level of being able to think and design systems that scale. And even though it's hard, and I'm saying it's hard, you shouldn't be afraid of it. Dive in and learn what it's all about.
Yeah, just do it. It's the future.
Mm-hmm.
Cool. Sage, thank you so much for joining me today and sharing all your expertise. And again, congrats on the promotion. And, if this people watching after current, we'll share the link and as well to the YouTube video that will be uploaded after the event, so everyone can, go back and listen and learn from the recordings.
Sounds good. Addie, thanks for having me.
Of course, it was a pleasure.